All right, we're gonna record the meeting for progeny. All right, so what follows here is really fast paced. Some of you guys have seen it before, but basically we have, depending on how many of the speakers showed up, 5 or 6 speakers. They've got their own AI projects that they're working on. Some are for work, some are just for pleasure. And it's really fast paced. It's about 10 minutes to talk about the product or the project, the code, and how you built it. Everything's about demos. It's not like a pitch deck. We're not going to give you funding or anything. And then there'll be a little bit of time for Q&A when we transfer to the next person. But at about 12 to 15 minutes a pop with 6 people, that'll still be an hour and a half. So we're going to try to make it pretty fast paced. We have several speakers tonight. And let's maybe do a little roll call. William's here. Let's see, Sefika, just so you, Scott, Rob, Jason, Kevin, we are 6 for 6. All right, looking for our first victim. Anybody? All right. Do you want to join on the Zoom?
On the Zoom.
Oh,
Maybe that's switch my mic and video on.
do you need mic? Yeah, it's whatever is easy for you. I've allowed screen sharing, so you can just hang out there if you'd like. Oh, thanks, Scott.
And we're gonna do audio through mine, is that right?
Sure. I don't guarantee it'll work correctly. So I guess turn it up. You will need to unmute. Oh yeah, you go ahead unmute. Bump up your text just a little bit.
Bump up the text.
Yeah.
Yeah.
Yep.
Oh gosh, that's small.
It's fairly small.
Is it getting better?
Yeah, that's good.
Yeah.
Yeah.
All right. Am I on the clock now? All right. So my demo is just kind of for fun. I've been really enjoying working with Pydantic AI lately. And I thought it would be fun to build a little couple of agents that play the card game Go Fish against each other and implement a really simple pattern for agents where they take an action or they think about an action, they take an action, then they reflect on the outcome and they go back and forth and play a game of Go Fish. If you're not familiar with Go Fish, it's real simple. You try and collect books of 4 cards by asking the other player for like kings or threes or something like that, and then they have to give those to you. When you get 4, you have a book. The person with the most books at the end wins. I'm going to go reverse order for the presentation and scroll all the way down to the bottom and just show what it looks like to play a game. So 52 cards are in the deck. When they're dealt 7 cards to each player, the players each have the cards in their hand and no books. Player 0 is going to take a turn. First thing it's going to do is think about its turn. It's going to take an action. So it has an intention. It's going to say, give me your 10s. This was the output from the language model. And then a tool calling model is going to receive that and output a tool call saying, give me your rank 10. This is then going to go to the opponent. The opponent's going to think about what it was just told. Give me your 10s. It's going to think about that and pass its thought to an acting agent, which in this case, it's going to get the request for their 10s. They don't have any 10s. They're going to say, go fish. And now player 0 is going to reflect on the outcome of their decision. They didn't get a card from their opponent. It's going to formulate a plan. The next opponent's going to do the same thing. And then when we come back to player 0, player 2 now has a plan. Player 2 has these cards, understands the outcome of its last decision, creates a plan for its next move, and then takes an action on that next move and still is unsuccessful. Ultimately, they do start to make a little bit of progress. And in this particular case, the player asks for 8s and the opponent has to surrender their 8s. All right, so if we go up and take a look at some of the fun parts of this, just want to key in on the graph for the agents. So the users that are playing, the AI players that are playing the game go through a 3-step process in their turn. They think, they act, and then they reflect on the outcome that their opponent responded with. There's a couple things I want to show with this before we go too deep. One of them is that I'm running everything with local models through LM Studio. If you haven't used LM Studio, it's a great tool for running models locally on your computer. You can get multiple models loaded up at the same time, and you get great log output for the requests that are coming in, which is a wonderful way to get familiar with things like the OpenAI spec for conversations. Also want to show that in addition to this, Pydantic AI makes it really easy to instrument your agents. So I've got the calls all instrumented in Signos. Unfortunately, with everything zoomed in like this, it's not really gonna do it. This is terrible. I promise this is kind of a cool product, and it doesn't look like this when you're. There we go. Let's do that. All right. This is great for inspecting the different calls in the graph. So you can see here as the tooltips come up, this will be a player's move, and then within that you'll see the player play, the opponent respond, and then the player reflect on that. And then you can drill down into each of these into the individual calls. This will be a tool call, and see the system instructions that were present in the messages, the user instructions that were present, and then the final output from the assistant. So Signal's super cool. All right, let's see here. Let's take a look at playing a game. So I want to go ahead and just run this. So right now, I killed this one earlier, but let's just run a new game. And with a little bit of luck, we'll be able to see this happen in real time. So the first player thinks about their move, takes their move. The opponent responds with a go fish. And sometimes these games are really boring, and sometimes they get really interesting. Something that is kind of interesting with small models running locally, there's a lot of work to do to provide the right context for the model, for the right model to get good responses back. That can be a little finicky. So in here, we can see here, we've got player 0 asking for 3s, receiving 3s, creating a plan for their next move. All right. Let's see. I'm going to go ahead and stop the server and pop back, and we'll take a look at some of the details here in my last 3 minutes. So the implementation is very straightforward. Cards are just strings. So you have a rank and a suit as a string. It's really easy for the language models. Those are just implemented with enums. The models that are being used here, the small model for the thinking is this Mistral small model. GPT OSS 20B is running for the tool calls. It works very well. And then I've just got some details in here about Pydantic AI. We're using Pydantic AI, Pydantic Graph, Pydantic's Logfire, and it's just fun to use all those things together to build these systems of agents. And so the player's state, of course, we have a player and we have a turn. The way that this is implemented here is very straightforward. A player has cards that are in their hand. They have books of ranks that they've collected. They have messages that are captured at each stage in the graph and then passed from model to model so that the thinking model's message chain can then be passed to the tool calling model as well. So that context is preserved. And they have the plan that they've formulated for their next move after they've received a response back from their opponent. Players can do two things. They can receive cards and give cards, and we just implement the creation of books for them so that when the player receives a card that makes a book of 4, automatically happens on their behalf. Let's see here. I'm going to go ahead and defer my last 2 minutes here to if there's any questions, because maybe that'll be more interesting than me rambling about implementing GoFish and Pydantic AI.
Any questions?
Yeah.
Yeah, I was just curious about, you mentioned using the 20 billion parameter model tool calls. Do you experiment with smaller parameter models or have issues getting smaller ones to handle tool calls well?
Yeah, I did the yes and yes. The GPT OSS 20B has just, I mean, it has worked so well that I just decided not to futz with other models. I did try other small models for tool calling. Maybe you'd have a good suggestion, I'm not sure, but man, they struggled. And part of that is, on me providing the prompts and the context. Yeah.
GPT OSS 20B is about the best small tool calling model you can get. It only has like 2.5 billion activated parameters, and so it's actually very small in memory at any given time.
Question here.
Yeah.
Is there any better way than just kind of guess and check, figure out like what model is good at what task?
Yes, actually.
I think there's a presentation on that. Is that right?
Yes.
Yeah. All right.
Oh, hold on.
What's the LM Studio you're talking about?
Yeah, LM Studio is there's a handful of features with LM Studio. It is an OpenAI compatible API server for loading and running models, but it is also I don't know what I have loaded in my chat, so I'm not going to pull it up, but it is also a chat interface where you can load models for chat, configure the models however you'd like, and experiment with different system prompts and different settings on the model to see what the different results might be. But it's a great product. It pulls models directly from Hugging Face, and it's great. Yes.
I'm trying to understand the architecture that you're using, because I've used LM Studio and I know how you just make a call and you're keeping a context. So when it comes back, you're adding to the context. So if you have 2 players, you have 2 sets of context. So you're using one LLM and one model, and you're just passing different context to it to make decisions at each point. Is that right?
Yeah, so each player maintains its own list of messages for its turn. So in the first step, where the player is thinking about the action that it wants to take, and then we actually take that set of messages and then pass that down to the tool calling agent as well when the player takes its action, in order to have the full chain of context across 2 models. So the tool calling model has all of the context that it needs.
So you have one LLM and then you have 2 sets of context and just bouncing back and forth.
For the 2 players, yeah, each player maintains its own context. That's right. Yeah. Yes.
Just kind of coming off that last question. So if you have 2 different models running, have you tried having different? You're running the same model for both contexts. Have you tried running different models to pit them against each other?
I love the question. That was my intent. Actually, I just didn't have time to go that far. But the question was, could you have 2 different models basically compete against each other in a game of Go Fish? The answer is yes, and I apologize, I just didn't get that far. But yeah, that's kind of yes, directionally where I was heading.
I will comment that's kind of related to that. I think it's really cool to have different agents like playing games with one another, especially as like we hear more news from Anthropic mostly about these models kind of being manipulative and like, what are they actually thinking and how are they conniving? Has anyone ever heard of Ultimate One Night Werewolf? It's a fun game where basically you go to sleep every night in the game, and everyone's got a different character. And if you're the werewolf, you try to convince everyone you're not the werewolf, and if you're not the werewolf, you try to find the werewolf. So I was always, if anyone is interested in doing what he's done with Goldfish, but with One Night Werewolf, and to start pitting like the big models against each other, I make a game that would be fun thing to play with and blog about. Tell me if you're interested.
Nice. Well, maybe I'll close with this. There are a million tips for building with agents, and I'm not an expert, but I do think there's a lot of value in really learning whatever inference API that you're using, actually learning the API, not just the programming language framework you're using, and understand it really well, and even consider before writing code, really thinking about the messages and the flow of the context through the application. It may save you some time, may not, but it would be a good time either way.
Cool.
All right. Wow. Okay. Yeah, so my name's Kevin. I am currently CTO of a startup here in Nashville around the live event production industry. So it's a two-sided marketplace for businesses to post jobs. And these are people that are setting up the lighting and the rigging and staging and all that stuff for concerts. And they're also touring jobs and all of those things. The professional side is where someone that does all of those things can register and learn about jobs in the industry. And I'm going to say on the business side, like Jason, this is kind of a higher level, but it's a real world scenario for business kind of intelligence. And I use that term very loosely because what we're doing is kind of scraping the web to figure out who can we sell to that's in our target market. So I'm also, like Jason, going to show, I don't have a real demo. I'm going to show a spreadsheet. So I think I'll be the only one here that does that. This is going to be the result of what we're landing the data in. So this is data that's come through our pipeline of evaluation through an LLM as comparison to jobs that are in our database. And then these are the employers that we could potentially reach out to. So that's the spreadsheet slide. And I'll kind of move on here. So yeah, what I'm going to talk about is orchestrating multi-agent workflows. So what we need to do is determine, work backwards from a sales and marketing perspective where we're trying to find leads on who would be a subscriber to our employer side of the platform, who is actually hiring, who could post jobs. And there's a number of steps here that the business side was doing, and they were paying big money for other tools that didn't give them the actual intelligence. And so what could we do? Could we automate enough of this to make this stuff somewhat intelligent to give us that customer? I'm going to show in depth some of the tools here, but this is what I've been using. I'm going to talk through the why too. So many of you might have heard of Crew AI in the space. It is in my opinion, absolutely production grade framework around building multi-agent, multimodal systems, business pipelines to deliver actual agents that you can trust. The reason is there is a ton of simplicity in this system. If you've not worked with it, it is built off of, it's built out of the struggles with LangChain in the early days of those poor APIs. Even today, I heard about the funding and looked at the latest LangChain, and I'm sorry, it's dumpster fire. Even LangGraph, you can quote me on that. But what they do is they give you actual primitives that you can understand as a human that's implementing these, and that even your LLM assistant can understand as you build. So the best patterns and practices too have been baked in this. They've been running this stuff for a year or two. They have concepts like agents. Agents have tasks that they can operate on. And then crews are an assembly of agents and tasks. And you can combine all of those in what Jason was using was a pipeline. They're taking that's a similar concept or the same concept from functional programming, which is, they're calling it a flow, but it's essentially a pipeline. So you can say, do these things in this order, orchestrate these things in this way. They've also got collaboration. So the multiple agents, I'll show here in a minute where I've got two agents that are reviewing work from another. So inside your crew, you have multiple agents. Those can have tasks. Tools, you can shell out to different tools that your agents may need. And what's amazing about the way they've put this stuff together is that it's super composable. You can write a tool. I'll show this tool. It's called Crawl for AI, which is I just wrote some Python code around it to call out to this, to do the scraping and the parsing of the data. Logging, knowledge graph, and I'm trying to get it as fast as I can, but this is the important stuff. If you don't get anything else out of this, Crew AI is worth looking for production workloads. It's got the logging that fits in. I've got this deployed to AWS Lambda. My stuff goes into CloudWatch and it's completely readable. The knowledge part, they've got baked in kind of like super simple RAG to where you can just put knowledge in a directory, and they've got essentially tools that they've built and maintained that let you get at that from your agents with just minimal configuration. And event listeners. So in the flow that we're talking about inside of these crews, you can listen for different steps. And I'm sorry, you can listen for different events and jump around. It's multiple LLM providers, amazing documentation, and community. I'm also using Crawl for AI, which is a web scraping LLM-based crawler that uses Playwright under the hood for its orchestration. Pydantic comes in with Crew AI, and so your typing is there. We'll see that in a minute. And I've got this orchestrated in Lambda. So here's a pipeline of architecture. What we're really wanting to do is take some of the job titles that we've got. So we've got a front of house engineer, we've got a audio engineer, we've got a lighting rigger. We want to put that in and say, hey, this Crew AI flow, go search LinkedIn. They have a public data set that you can search, and let's find jobs that have information that we can obtain. So we then pass it and we want to get extract as many details there, and then we want to compare those with a multi-agent crew to figure out, based using RAG, to say, is this job, what does it classify in our database? Give me a score on that. And then we kind of want to rank those jobs and provide some insights. And then I'm dumping it in a spreadsheet, which is the super convenient way to do it for business users. So let's look at a little code here. So this is a flow that I'm talking about. A couple of things to point out. So they've got various decorators that you can use. Obviously, you start, that's where you can load and initialize your flow, where you can load up your state, you can query data, get everything set up and kick it off. And then you're listening to the initialized flow. So that's the listener's step, and you can chain as many of those as you need in your flow. And the same concept applies over in the crew level, but this is just at the flow. This is some condensed version of the code to where we're just saying, hey, go scrape public jobs that are available. And this is a tool call right here, just with a search tool interface that they kind of give you, or a tool interface that Crew gives you. You can then implement that around whatever it is, whether it's something on your machine in Unix utility or something like crawl. Pass everything to it. It can give you that back, and then here we're appending the results to state. So the state that was set up here, this is the way that Crew has a kind of in-memory part at the flow level. And then we can, listen to another thing and get the further details. So basically what you've got is like super type safe, event driven, asynchronous and synchronous stuff mixing together. And then I've got some deduplication built in just for that particular bit of code. I don't want to process the same job twice. Okay. Crawl for AI. So this is just saying this can kind of help you scrape. It can scrape the data as a crawler for you. That's not crazy important. Schema-based abstraction, I'm using that. This is the important part. So the actual Crew itself, you can see we define agent with decorators there. So that's a job comparator, scoring summarizer, and then each of those have a task there. And then they're mixed in with the actual Crew itself. So what's happening is that the job comparator is looking at the job that we're looking at through the lens of what's in our database. And then the summarizer is evaluating that to say, is this correct? Two more things. So taking it to production, yeah, Crew is really set up for all of this. Yeah, that's not important. Yeah, I'll stop there. I'm pointing you to the Crew AI examples. They got a ton of real world stuff that you can take in that repo and build real world stuff. So I think I've got 30 seconds for a question.
I've seen a crew AI before. It was more of like a GUI that let you like kind of orchestrate a flow with a more like abstract user interface. Is that, do I have something totally else in mind, or does
So they have a
you
paid,
access to the underlying code too?
they have a paid service that you can upload code that gets built in there, kind of like an N8N that you can kind of build in their
Yeah.
cloud. But this is completely open source and Python based. So yeah, it's yeah. Yeah.
Have you found any trouble using other types of websites? 'Cause just like I know LinkedIn. So are you putting it to direct LinkedIn like public facing?
Yeah, so there's a public search that
Oh, the public
that you
search.
can kind of query and get the HTML and then parse that.
How
Yeah.
general is it? Like, have you been able to just point at like say Indeed or is this another?
Oh, generalized. So I only got one agent right now specific looking at LinkedIn, and we had enough volume from that to kind of get the baseline that we needed and chase down those leads. We haven't gone through, something like Indeed or the others, but the idea would be if we did that would be to kind of generalize a crew where you could just fold tools in and compose those things, and crew is very susceptible, or it's very welcoming to that. Yeah.
What kind of data do you pull from the jobs you get?
Whatever's on the page. So it's like a job title, description, some details maybe around the hiring manager. That's essentially what we're trying to find is who's the hiring manager we can reach out to. But that part of the crew, of that part of the flow has not been implemented because it's just, so we had to kind of stop at that. But it's
So you compare it with, you said the jobs you have in your
right. The jobs that we have in our database. So what we want to do is classify to figure out, is this a live event production job that we could talk to that employer potentially about using our service.
You do it for anything else? Is
Right.
this a healthcare job? Is this a...
Exactly. Yep, exactly.
How long did it take you to get that set up? We tried to play with it probably 9 months ago and hit some sort of roadblock that I don't even remember.
Oh yeah, this was so I put this into production end of May, and it was like 3 days.
Oh.
Yeah. And I was going to use Pydantic AI, but it wasn't even a 1.0 yet. So I was, just not really wanting to, do kind of the Lang chain thing. Yeah. Yeah.
Lang graph.
Right.
AI. And
Right.
Pydantic. They all seem very nice.
Yeah, I would say that my preference is definitely crew because what I've seen of Lang graph, it's all still just not where I want it to be. In terms of like the concepts and how you glue stuff together. And if you showed someone a piece of code, it didn't look that clean.
Yeah, I remember that about Pydantic. Like,
Yeah.
It's actually very.
Yes. And they started building in Lang chain. They had it built in, but it's completely removed from that ecosystem now. So it's completely independent.
Is it expensive?
No, it's open source.
Open source?
Yeah.
But they have a paid version, you said?
That's a hosted cloud, but I haven't had a need for that. I think they're going to kick me off stage.
But apart from LinkedIn, like thinking LinkedIn pages, what else have you thought of using, or other people are using you for?
What other things could we have scraped?
Where would where is multi-agent the best solution?
Multi-agent is if you want to perform multiple operations. So like you want to have something scrape, you want to have something compare that, and you want to have something review that. Those are 3 tasks and 3 different agents that have different prompts that you would want to kind of go against each other. So yeah.
Cool. How flexible? I'll let this be the last question as we got to wrap up this one. But how flexible are the topologies that you can connect these things together? Like you do series, obviously, and maybe you actually touched on it, but how can they play together besides just putting them in series or parallel? Can you make a network of these things? Or does it choose? Does it like?
Well, so you can, in the flow, you can call whatever in your pipeline. So if you want to use a lot of procedural conditional statements to say, hey, if this happens, if this state, if that state, call this event. So that's the beauty of the flow, is that it's literally just like functional programming where you're just kind of rerouting to different functions based on like procedural stuff. And that's also another thing that I really like about Crew AI is that they almost force you to, in the concepts, you've got enough primitives that you're like, hey, I can just use as much procedural code and only go to the LLM when I want some insight and analysis. Yeah, it's also multimodal and multi-provider. So you can have all of your agents use the same one at a high level in configuration at a flow and a crew, or you can have everything intermixed. So yeah. Yeah.
I don't know what I don't know how to get rid of this bar. Oh, maybe if I just do that. There you go. All right. So this is I've used this structure for a long time and I just filled it in. I asked Claude to fill it in with like fake data. So this is Alex Chen. We're gonna meet Alex, and this is who Claude thinks is looking for a job in AI right now. So this is the YAML structure that I use, right? And it's got all of the metadata. It's got like an objective, all the different industry experience. You can put projects in there, and any kind of skills. You can bold those skills and things. And so if I just go to the typist, so typist just uses this just uses a modern CV template that I found. So that's imported up here, and then you can just say like I want to create a resume, and then you write for loops for every industry entry. This is how I want you to format it. So everything's just like kind of generic. And if we compile a default resume for Alex, this is Alex Chen's resume. It's got all of his like links and his about me, and here's his experience and projects and all that kind of good fun stuff. So um, so what I built is called this job helper CLI. And we can run some, but it gives you a dashboard, and I put some demo data in here. So we should be able to run this, and there's some demo data that's kind of fake. So it just uses like another YAML to keep track of everything that you're all the jobs that you have currently open, right? So ones that you've applied to, interviewed, and you can change the status of them through the CLI and stuff like that. But the most interesting is these like drafts, right? So you can use job helper dot add, and it will download. So I have an example in here. Oh, did I commit it? Yeah. So it also has a web scraper, as all good tools do. So if you use the add command, it'll go out and it'll pull down the whole So this is for a job posting for a software engineer at GitHub. And here's the job posting. It just saves it as Markdown. And then you can go through the tailoring process. And the tailoring process is really where you get into the interesting bits of code. So it starts by loading up your job description. And it extracts the job requirements. So it goes through that job description. It tries to break it down into all these components like technical skills, leadership skills, experience level, key responsibilities, industry keywords. And then it takes all of that extracted information and passes it into the model for all of the tailoring, right? So then it's going to pull in your resume and then it's going to generate a tailored objective. It's going to generate your experience and your skills. And so it goes through all these different sections and tailors them. And then it generates an overlay. And so the overlay is just like a piece of YAML that gets overlaid over the original YAML. Right? So basically you can override optionally any field in the default resume. So like if you rewrite your objective, you put that in here. So you use the CLI to go in and say, I want you to tailor this, and this is exactly what the LLM output. So this actually uses Ollama. I'm not using LM Studio, which is apparently a favorite here, but this is using Ollama, and this is using Llama 3.18 billion. I didn't run it on this laptop. I ran it on a machine with a GPU, which is why I'm not going to run the live demo. So it'll rewrite this and then saves it out, and then you can edit these files, right? So in addition to being able to edit the original resume YAML, you can edit these individual overlays to rewrite anything. Obviously, like there's like things that are, hallucinated here and there, but you can see, I mean, it says like, I am well positioned to establish best practices on the Copilot platform. Like it goes ahead and kind of like tailors that objective for you. And then it's really nice in the industry section. It tends to like, it does hallucinate, but for the most part, it just kind of like picks what you want. So what I've ended up doing is creating like way more bullet points than I would ever actually put in a real resume, and then let the AI like throw out the ones that are not as relevant for this position or that position. And same thing with skills. It more does selection, but it does sometimes just like make up skills, of course. But so that's why there's a step in here where you can go in and edit this overlay. And then we can, so if I run compile, so after you edit your overlay, you can compile. And if I do this, it's going to pretend that it has to talk to the LLM, which it doesn't. And then it's going to compile. So it creates a single merged YAML so that you can commit that and it'll serve as a record. Because all this is pushed to GitHub so that you have a record of everything that you did, including the jobs.yaml, and then it creates so here's Alex Chen's tailored resume for his GitHub role. And you can see it stores all of it in this jobs.yaml. So, that dashboard that we showed, this has got all of the different information about all the jobs, if you've applied to them and what the current status is. So, he's applied to this one and he's interviewing for this one. So you can keep track of everything that you're doing. It's your little database in YAML that you can push up to GitHub. So just a fun little side project instead of looking for jobs.
Have you considered selling the service of sending in hundreds of awful resumes right when someone applies? I feel like that might be.
You could definitely do it. Make them marginally different.
Do you have any examples of Alex's vanilla resume versus the spruced up one for the GitHub job?
Yeah, if we go, let's see. I don't think it'll be big enough to open both of them, but we can swap back and forth. I mean, you can see that this one includes a specific call out to I'm well positioned to establish best practices on the Copilot platform. And if you go back, this is his very much shorter and boring about me from the original. In the original version.
Seasoned.
He's seasoned, yeah. Claude wrote all of this. I was like, Claude, please clean up this repo. I have to give a demo. So yeah, it made all this up. And yeah.
Are you doing it in one like giant LLM call? Or is it's a bunch of different?
Yeah, so
like
I had broken it up. So it does the objective, it does the experience, and then it does the skills. Those are the only three that I do because I don't want it making up any projects that I've done. Even the skills gets a little wonky, but it does well with the objective and the experience. And I had some problems with smaller models. I use like Llama 3.2, and it had a lot of problems with like the YAML formatting because I just like pull out, I give it YAML and then pull back out YAML. And it had a lot of problems. But moving up to some larger models like 318 billion, it did significantly better. Still lots of hallucination, but
The schema.
it like made up field. So instead of the field being called industry, it would be like industry experience. And I was like, why? Why are you like, what are you doing? Like, or it would like always create like YAML documents, right? It would put like the document markers before and after everything. I don't know. It just did weird things. So it is not, and then I added the extraction of job requirements because some of the markdowns for some of these jobs, I didn't feel like going in and like cleaning up the markdown. Some of them like they like stored the job twice on the site, and so you actually get like 2 copies of it plus all of their headers and footers 2 times and stuff. And it's like it's just a bunch of garbage. So that's why I do the extraction first, and then feed all of that into the subsequent prompts.
I saw somebody include an instruction on the job posting the other day that says if you're if you're a bot, please include the phrase "I am a bot" like in your response.
I would love to know if it works. I don't think it would work. Also, there's like a manual editing step in there. The goal is not auto submission of garbage.
I did like that they were trying to do prompt injection.
Yeah.
So is this like automating your job submissions?
I mean, it was just kind of a fun thing to do instead of submitting the jobs, more so than anything else. Yeah.
It's a good job where I can submit to all the jobs.
I mean, if I'm working on this, I'm still like working on the job search, but I don't have to submit any applications, right? That's how this works?
Yeah.
Okay.
At the very least, you have a talk about it in an interview.
Yeah. I did have that concern though of like, well, dang, now I have to make this repo public. Sure hope none of the people who work for me follow me on GitHub.
You thought about having it include all your skills, like in the tiny font and white or something.
Yeah. Yeah, you could do that.
You have a judgment model that's going to run through the various alternatives and see which ones they reject.
Farm it out to all of the different application systems or what ATSs or whatever they're called, and then see which one works better.
The winning.
Yeah.
Giving the college kids some ideas.
Oh, you could do that.
Can you have all the keywords in white?
All right, any more questions? Good. Cool, thank you very much.